Uh,
Assalamualaikum. Hello. My name is Muhammad Hafiz Imran bin Muhammad Fazil with meeting number 206-885. So we are from group 3. We will present about the heat transfer application in refrigerator and the cooling tower. Next slide. So we will start with the introduction of the refrigerator. A refrigerator is a household appliance designed to keep food and other perishable items at a low temperature. So to maintain a consistently low temperature inside the appliance, a refrigerator works on the principle of the thermodynamic, which utilize a combination of insulation, a refrigeration system, and the cooling medium. A basic refrigerator consists of several key components such as a compressor, condenser, evaporator, and expansion valve. Next slide. So this is the four main refrigeration cycle component. So the process begins at the compressor, which the compressor will compress the refrigerant, and it will cause the high pressure, vapor, and the high temperature. Then the refrigerant will flow into the condenser, which will change the phase from the vapor to the liquid. And after that, the refrigerant will flow through the expansion valve, will change the liquid phase to the vapor phase. And during this phase change, uh, the refrigerant will absorb the heat, and the evaporator acts will distribute the low temperature heat to maintain the low temperature inside the refrigerator. I will pass to the next presenter to continue the present.
Okay, my name is Zikri Virusli. Okay, in a refrigerator, heat transfer happens in two important parts, the evaporator and the condenser. First, I will explain the evaporator. The evaporator is located inside the freezer compartment. It cools down the freezer by absorbing heat from the air. Warm air from the freezer comes into contact with the evaporator coil. So the heat from the air is transferred to the coil and then to the refrigerant inside the coil. This cooling process make the freezer cool again. So for condenser, the condenser is usually located at the back or bottom of the refrigerator outside of the cooling area. So it releases the heat absorbed by the refrigerant in the evaporator. The hot refrigerant flows through the condenser coil, and as it moves, it gives off heat to surrounding environment. This heat release cools down the refrigerant, so it can go back to the evaporator and repeat the cooling cycle. So to help the heat transfer process, the evaporator coil is placed behind the freezer compartment. As warm air rises, it naturally move up toward the freezer. This allow the evaporator coil to absorb the heat from the air, making the freezer cold. This movement of air is called convection. So, in summary, the evaporator cools down the freezer by absorbing heat from the air, while the condenser release the absorbed heat to environment. This way, refrigerator keeps your food cool and fresh. That's all from me. Next.
Okay, my name is Muhammad Adam bin Umar Zaman. Okay, right now I'm going to explain in terms of case study of our refrigerator. So in this case study, the walls of the refrigerator are typically constructed by sandwiching a layer of insulation between sheet metal panels. So consider a wall made from fiberglass insulation with thermal conductivity and thickness given here, and the sandwich of the steel panels properties also is given. So the T infinity is the temperature inside the refrigerator is 4 degrees Celsius, while the temperature outside is 25 degrees Celsius. So in this case study, we need to find what is the heat gain per unit surface area with the given properties. Next slide. So this is the overview of the refrigerator. So on the left side or on the center, you can see the insulation, and on the left and on the right with the properties, you can see the metal panel sandwiching. So below you can see the properties of refrigerated air. On the bottom right, you can see the properties of ambient air. Okay, so this is an important step into solving this case study, with also the length given below there, 0.06 and 0.04 for the metal panels. So next slide. So what we need to do here first is to construct a thermal circuit, as I have stated, as I shown right now on the top. So after we constructed the thermal circuit, from left is the inside of the refrigerator, and on the right is the ambient outside of the refrigerator. So the thermal resistance is equal to RT, is equal to R1 until R5 of addition. And because R is like a resistance, it's actually 1 over R to calculate the total resistance. So instead of resistance like the electricity, we use the properties that are given in the question just now. So after we substitute the values, we can calculate the total thermal resistance is equal to 1.7045 ohm. So from this value, we can calculate the heat gain per surface area, which is Q over A, which is equal to Q double prime. Q double prime is also equal to the difference in temperature over the thermal resistance that we calculate just now. So the temperature difference 25 is outside minus temperature inside is 4. So over with the thermal resistance just now will add up to a Q double prime of 12.32 degrees Celsius. So that is the end of our case study for the refrigerator. So I'll pass to the next presenter.
So, Assalamualaikum and hi. My name is Muhammad Iqra Afiq Medis and my metric number is 20563. So, for the cooling tower, this is the one of application that we chosen in industry. So, what is cooling tower? So, the cooling tower are heat exchanger system used to cool water or fluid. They are commonly found in industry facility, power plant, and a large-scale air conditioning system. They utilizing evaporative cooling to remove excess heat. The design and the operation depend on factors such as cooling capacity, water flow rate, ambient condition, and the application itself. So next slide. Next slide. So as you can see in the video, this is the process of the cooling tower and the component of the cooling tower. So by that, for more information about the process of the cooling tower, I will pass to the other presenter. So that's all for me. Thank you. I will pass to other presenter.
Okay, my name is Amirah Haras Pembuli Zaman. My metric number is 206723. Okay, the concept for the cooling tower is a unique cooling tower is a unique type of heat exchanger that enables the interaction between the water and air to lower the temperature of hot water, and a small amount of water evaporate, leading to a decrease in the temperature of water circulating in the cooling system. Next slide. Okay, how the cooling tower works. Okay, first the hot water enter the tower, and the hot water will spread over the material that called fill. Fill media will increase the surface area of the hot water to allow the cooling process rapidly. So after the cooling process have been succeeded, the cool water will be collected at the bottom, and the cool water is returned to the process or equipment. So by this we can see there is a conduction process, which is from the hot water and fill that allow that increase the surface area of the hot water to cooling and convection between the molecule of the water. So I will pass to the next presenter.
Okay, so for the case study of cooling tower, some example is like in the slide, which is now consider a commercial cooling tower with a 50 liter per second water flow rate, a water specific heat capacity of 4.18 kilojoule kJ times K, and then put temperature of 40 degree. And the question is, what is the rate of conventional heat transfer if the temperature is 30 degree? So first of all, we list all the things that have been given, and change it to suitable variable, which like water flow rate. From 50 liter per second, we change it to velocity 0.05 m acceleration. Then by using all the variable that have been given, by using the formula which is Q equal to MCP, in the bracket T inlet minus T outlet, and putting all the value, we get the value of 2090 kilowatt, which is the heat transfer rate through for the question. So I think that is all for our group about cooling tower and refrigerator. Thank you.